In order to calibrate the rain gauge, I need to measure out 500 milliliters of water as close as possible. And I'm going to assume that a milliliter of water has a mass of a gram. So I'm going to tear the scale right now. So that's the 0. And I'll fill it to be as close to 500 grams as possible. A little too much. Look at that, within a couple grams of it. If I can get within about a gram, I'm pretty darn close. That's less than 0.2% error. I'll go with 501 grams. Okay, then what I'm going to do is I'm going to pour it in this device that I built, or a student of mine built a few years ago on my design. This is a funnel in here. I'm going to pour it into the funnel. You can barely see. And you can see the water sitting in that funnel. And what happens is it's going to sit in that funnel until I turn on a pump that's going to slowly pump the water through the rain gauge. The rain gauge has a data logger in it that's going to record the number of tips. So I'm going to turn it on now. Here's the power supply. Turning it on. You can hear that the pump's running. It's pumping the water down. And you're going to hear a click every few seconds. Just waiting for that click. That was the first one. So it's going to keep clicking until the whole half liter of water is gone. And the click should be spaced pretty evenly because the water is being pumped at a very even rate. So I'll be able to determine from that, as long as the tips of the rain gauge are even, I'll know that the water was spaced out appropriately. The water can back up occasionally in the rain gauge because of films and other things on the drain of it. And I've had that happen where it backs up, then you get a few tips that happen very quickly. That's a problem. This is the process of calibration, and we'll take a look at the data from this rain gauge after the full half liter is pumped through it, and we'll make sure that we know how many tips correspond to a liter. And it's slightly different for each rain gauge. And I try to do this every year for all of my rain gauges, both because the calibrations can change, and also because I want to make sure that the rain gauges are still working. It finished, so I turned off the power supply, and I'm going to take off the pump, and then I'm going to take off the rain gauge, and I'll bring it somewhere safe. I'll take the lid off of it. It's hard to do one-handed. I should have a tripod here, but and this is number 64. I have 64 written all over the place. You can see a little bit of water remaining in the tipper. It's inevitable. It leads to the uncertainty. So you won't necessarily get the same exact number of tips. It might have started on the opposite side, and maybe one side takes a little less water to tip than the other. So things like that can happen. Then I have to take this off. Take this blue. Note that I then take off the blue cover, number 64. I make sure that number is apparent all over the rain gauge. You can find it everywhere. So I want to make sure 64 stays with 64. All the pieces of it stay together, particularly the base and the cylinder here. Inside the little compartment here is the data logger that's connected to the rain gauge. It counts the number of tips. I'm going to pop it off. And then I'm going to plug it in to the proper cable on my computer. It has to be a PC, as it turns out. So I'll do that. Now I'm going to download the data Unfortunately, it's not from the same rain gauge. My recording software didn't record that one for some reason. So this is from a different rain gauge, but it's the same idea. I connected the data logger to the cable that's connected to this computer and running this software. And this is software. And what I'm going to do is I'm going to tell it to stop collecting. So I'm going to press stop. Then I'm going to press download. And now it's going to download the data, and you can see it here. Here's the data, and it's nice and evenly spaced, which is good. It means that the rain gauge was responding pretty much as I would expect it to. And I could count those number of tips. Each of those vertical lines represents a tip, or I can export it to Excel, which I'm going to do right now. Don't need a chart to be displayed. So every one of these tips is a valid rain gauge tip associated with a half liter of water that I put in. And here's the data. And I think you can see it here. And what I'm going to do now is I'm going to, you can see it goes all this far. And each one's separated by about, between 14 and 16 seconds. I think one of the buckets took 14 seconds to fill. The other one might have taken 16 seconds to fill, plus or minus a second. So pretty close, but you can see there's a slight difference. So there's a small asymmetry, but not one I'm going to worry about, although it maybe could be adjusted. But it's within, I think, tolerable error as far as what we're concerned. So I'm going to take the sum of this. So in Excel, I'll say, give me the sum of everything that's between C8 and C100. That'll definitely cover everything. That gives me 59 tips. So 59 tips were associated with a half liter of water. So for 1 liter, that would be 118 tips. And this is bucket 41. So this header information I'm really not interested in. I'm going to delete that. Actually, I'll delete all these rows. And I'll actually insert a row. And I'm going to call this bucket 41. And I'm going to add this information to the information I already have for bucket 41. I have an ongoing record for each bucket that I calibrate and recalibrate, so I can see the history of the numbers. That is the calibration procedure, and I do this for every bucket, typically every year, so that I know the bucket's working and so that I get an up-to-date calibration number. Now, they shouldn't change much, but sometimes they do change a bit, so I like to have it at least once a year updated.